This is example 10.3 from Discovering Design with Chemistry. It says a gas occupies 750 milliliters at STP. How many moles are present? So let's look and see what we have so far. So we have a volume here. We have STP, which tells us that the pressure and temperature are standard. And then it wants to know how many moles. So we're working in moles. So of all these different equations that we've learned so far this chapter, this one contains all of the symbols. So we have pressure, which is 1 atm because that's standard. We have volume in milliliters, and we can convert that to liters. We have, well, we don't have N, but that's because that's what we're going for. R is given. We should memorize this. And then last, we have temperature, because that's also part of the STP standard. Temperature and pressure means 1 atm and 0 degrees Celsius. So we have basically everything we need to plug stuff in. So let's write out our equation and then let's rearrange it so that this N is by itself. And then we'll plug everything in. So the number of moles is the pressure, which is 1. So I don't really need to write that. Times the volume. And it has to be in liters. Should have written 1 atm here, because we'll need it to cancel out. So obviously our temperature is just going to be 273.15 K. And it's important we put that in as that because the liters are going to cancel. The pressure is going to cancel. And then down here on the bottom of the fraction, this will cancel. And this last unit, mole, is on the bottom of a fraction on the bottom of a fraction, which means it'll flip to the top. So we'll have the number of moles once we put all of these numbers into our calculator. Oh, drat. I meant to make the 7,500. I missed my decimal point. Let's try that again. There we go. So we have 4. So we need to round this to 4 decimal places as our, not 4 decimal places, 4 significant figures. So we have 0.0334. Not 4 decimal places, 3 decimal places. So that's our answer.